all right. So yeah, we're going to finish the day on, sorry, I'll stay in front of the microphones, finish the day on digital sustainability. I'd normally be apologising to an audience at this point for hitting you with an awful lot of facts and figures very quickly. But after the presentations I've seen today, I'm going to apologise for not having nearly enough facts and figures and absolutely no consoles. So what I want to cover is a quick introduction to myself and the company, P20, a background to sustainability in its broader context, and then a specific look at digital sustainability and some specifics that we can do around making a difference from a digital perspective. So from my point of view, I've spent the last 7.5 years working in sustainability. Transition for me came about on a trip to Iceland, which I predominantly went there to take photographs. But a local guide took me out on a glacier and actually physically showed me the retreating glaciers and explained what was happening with the exposing the volcanic soil and the heating and the acceleration of change that was happening with her environment across the country. So I've been working in sustainability ever since. I've done projects for several of the sponsors here, so a lot of the big tech companies, people like Microsoft, Google, AWS, using contacts that I built up over the last 25 years. So the previous 25 years, both inside a big organization and then running an enterprise end-user computing and management services consultancy for 20-odd years. Prior to that, I worked in management services on large-scale business case analysis, which is also, as we'll see later, coming quite useful. From a P20 perspective, been going now as a separate business about 18 months. Over that time, analysed about nearly 750,000 devices in 162 different countries. My customers range across central government, finance, retail, education, pharmaceuticals and not-for-profit, plus a load of tech companies, as you might expect. Also, as of the beginning of this year, I was asked by DEFRA to take on a role for the UK government. So I now chair a working party reporting into DEFRA, looking into government supply chain to about 630,000 UK government employees, looking to rationalise that supply, improve the reporting and encourage best practice across government in terms of their emissions reporting. So all the slides are available, by the way. I think they'll all be sent out after this, just to keep you up to date. So sustainability as a concept, need to start off by making us all feel very small. Earth being 4.6 billion years old, human beings appeared during the Pleistocene era, about 312,000 years ago. So if you took this as a sort of a projection over a year, we appear at about 25 past 11 on Hogmanay. So we've not actually been around for very long. And most of the time we have been here, we've been in a period called the Holocene. So there's about 12,000 years of that, which is the period after the last ice age, which has been very benign, called the Goldilocks zone, where the temperature and the atmospheric conditions are really optimized for us populating and propagating as a species. We have done so much damage in the last 75 years that a complete geological era has been proposed for us, which starts about 1950, called the Anthropocene. So we'll have a look at what that looks like. But if we take that 312,000 years of human history, from when we first appeared through to today, up until the Holocene, we added less than half a person per year to the human population. So very slow growth. We had a lot of reversals, sudden die-offs, all the rest of it, very few people being added. Throughout the Holocene, so up to 1950, we added 167,000 people a year. Does anybody want to take a guess on how many people a year we've added since?
1 million.
Sorry?
1 million.
A few more than that.
100 million.
80 million people a year we've added since 1950, which means that 7% of all the human beings who've ever existed on the planet are actually alive today. which is quite a staggering thought. Now, if we look at the impact of this on the planet, and there's a lot of data on this slide, but bear with me. So we're starting back 12,000 years ago, running forward to today. We look at our total energy use over that period. So we're burning biomass and a few bits of coal that we can find lying around. We start extracting that industrially during the Industrial Revolution, 1950s, post-war economic boom, electrification of manufacturing, global supply chains, boom, off it goes. Of course, the good news is that we're generating sustainable energy now. But if we map on our use of fossil fuels, we're just topping up. Our use of fossil fuels is still rising year on year. And we can see why. There's the population. It's going up exponentially, quite literally. It's doubling over a fixed period. If we look at atmospheric concentrations of carbon dioxide in parts per million, the most we've ever seen in the last million years is 300. As of 1950, that starts to go up dramatically as well. So it's gone up 42% more than that previously seen maximum, and 35% since 1950 alone. Consequently, when we look at the temperature, and this typically lags 10 to 15 years behind the atmospheric CO2, again, we can see that start to climb as does atmospheric CO2, traps the heat, and we end up above the UN target set in the Paris Accord of 1.5 degrees. January 2025, we were up at 1.75 degrees above pre-industrial average. Remember, this lags 10 to 15 years behind what we're actually putting into the environment, and what we're putting into the environment goes up year on year. So there's something called Earth's overshoot days. Anybody come across that? Okay, it's a calculation done by a not-for-profit organisation looking at when we've expanded used all the resources that the Earth can replace over the course of 12 months. So the red bit is us in overshoot. We're into overdraft. So as of last year, it was August the 1st, which means we would need 1.75 Earths to support the way we're currently living. They also produce a by-country visualization, so that you can look on that and see if all the world lived like certain countries, when would we use all our resources? To save your eye strain, we're down there in June, which means we'd need more than 2 planets. And we'll come back to it in a minute, but the United States and Canada are up there in mid-March. So we'd need 4 Earths to support that way of living. So how are we doing it? Quite simply, we are running an overdraft using fossil fuels. We've got 8.2 billion people on the planet, and on average, they consume the equivalent of 10.26 barrels of oil equivalent per annum. Now, if we convert that back into human effort, human labor over the course of a year is about 10,000 kilojoules. So each of those barrels of oil is worth about 4.5 years of human effort, which means that for every person on the planet, we have 46 full-time fossil fuel workers working on our behalf. That's on average. The UK, it's 56. But if we take the US and Canada, which is obviously presented as an ideal for other people across the world to emulate, it's 164 fossil fuel helpers every year. And if we actually had people doing that, we'd need 1.3 trillion people on the planet. So we are running this overdraft using fossil fuels, and it is quite literally unsustainable. So if we think about it, we're consuming fossil resources that were laid down 300 million years ago, and we're using them 10 million times faster than we're replacing them, because it's not a very quick process. The known reserves of fossil fuels, natural gas, we've got 47 years left, oil 52, and coal 133. That's at current consumption levels. So we're using this stuff as if we have an inexhaustible supply, as if our overdraft is never going to have to be paid back. But we don't actually have the resources to continue as we are, because we keep using more, and there's a finite amount of this stuff left. But obviously it's not just fossil fuels. There's rare earth minerals, rare earth materials, rare earth metals, depending on how you want to configure the REM. you'll see this flowing through into global politics at the moment. So we have about the same reserve of these as we have of coal. It's about 133 years worth of these materials, but where they are may be more of an issue, because 34% of them in China, 15% in Russia. So 15% of these metals are stored either in Russia or China. So only 12% in the rest of the world outside of Brazil and Vietnam. So the strain on these as resources could very well end up with us being in a very difficult position if we depend on these resources for the way we live today. So where does this take us from a digital sustainability point of view? Well, there's a flow of materials around the world, and a large proportion of that is flowing from the southern hemisphere into China to make the IT equipment that we use today. So about 45% of the petrochemical reserves are flowing from the Middle East and Russia into China, and about 44% of the rare earth metals extracted are going to China, which makes about 64% of the finished goods, which are then exported back around the world through distribution points to point of use. So about 30% of that finished IT equipment ends up in North America, 36% in the EU, and 14% in Japan. A lot of that at end of life gets recycled, and we'll talk about the importance of that in a second. Recycling rates are fairly good in the EU, 43%, 54% in Australia, which is excellent, but North America, 15%, Asia, 12%, and let's not get started on South America and Africa. There's very, very low e-recycling going on. But also, quite a lot of this, in particular from the US, is coming back into the Southern Hemisphere as unregulated e-waste. So it's being exported from those countries, supposedly under e-recycling programs, and is then being burned in open landfill sites in Western Africa, in India, and in parts of the Far East. Extremely bad for the environment and extremely bad for the people that are doing that. So we have an issue in terms of the extraction of those resources from the ground in the first place. So about 50% of the world's greenhouse gas emissions come from extracting and processing the resources for manufacturing. And that's going up. We need more of these resources because we have more people and we make more stuff. To make a 1 kilogram computer requires 400 kilograms of those resources to be extracted. Again, the demand for materials is growing. We're making nearly 2 billion new personal computing devices every year. And although most of those are smartphones, nearly 500 million of them are actually tablets, laptops, desktop PCs. Now, you can cut the numbers in all sorts of different ways. The fact is that the IT industry as a whole contributes something like 2.5 to 3.5% of the world's greenhouse gas emissions, which is greater than the impact of the aviation and shipping industries combined. And that is only going up, particularly with the impact of artificial intelligence, cloud. We're expecting data center use and data center emissions to double by the end of next year. But that waste is building up all over the world. In the UK, on average, we have 9 connected devices, excluding Internet of Things, 4 per person, and 20 unused items of electrical equipment hanging around in the house. Now, these have got the rare earth metals. They've got gold in them. They've got aluminium. They've got steel. They've got all sorts of reusable components. But we have no easy means of recovering those, certainly not at scale. We also, in the UK alone, have enough unused cables to go 5 times around the world, which is a fairly scary concept. And in the EU, in the UK, we are the second worst in the world for the amount of e-waste that we actually dispose of. Worst in the world is Norway. We're number 2, but we're 3 times the world average. And although a lot of that is going into e-waste recycling, it's a huge figure. So when we talk about digital sustainability, there's really 3 key areas that we need to think about. So one is planetary impact, which is digging those resources out and then what happens to them at end of life. One is carbon footprint, which is the actual calculations around carbon footprint, which I'll talk about in a moment. And then the other is the promotion of circular economy. So how can we break this link between things being dug out of the ground and ending up in landfill? And that really comes down to the resources that we use, how we reuse the devices when we finished with them, and then how do we recycle them at end of life. So there's lots of things that we can measure as part of this. And one of the key things that we do as an organisation is we're working with companies and working with the government to improve the metrics around all these areas. But that's not enough. Everybody's very obsessed with measuring these things, but in actual fact, what we want to do is turn it into a prioritised action plan that actually delivers change. And that's the difficult bit. So getting the figures is difficult enough, but persuading people to do something with them is even harder. And part of the reason for that is there's an awful lot of complexity in this area. These are all the sorts of questions that we discuss as part of the government initiatives. And it's everything from the people impacts to all of the different impacts of the chemicals, of the extraction, waste, water, plastic. There's so many different parts to this that it gets very difficult. So as part of the government working parties, we've got Amazon on there, we've got Microsoft, we got a lot of the big SIs are working on this with us as well, trying to answer all of these questions into a government strategy. So we're currently working on the government strategy for the next 5 years and contributing to that as to how the government starts to meet its net zero obligations and targets. And that's suggestions that are coming through from the IT industry to government and then out to the public sector to try and improve our performance in these areas. Now, I'm not going to talk through all of these. I'm going to focus on one area, which is carbon footprint reporting, because it's probably the simplest to discuss within the time available. So carbon footprint reporting is typically something that's included in environmental and social governance metrics, so it's of interest to the private sector. It's also of interest to the public sector around those government commitments, things like the greening government ICT commitments. It's based on something called the Greenhouse Gas Accounting Protocol, which I will not bore you with because it is pretty much to do with accounting for greenhouse gases, as you might expect. But it's a way of calculating your progress towards net zero. And most organisations now, certainly the listed ones, have got a net zero target somewhere between 2040 and 2050 for most of them. So there's three sort of main ways of calculating your carbon footprint. One is spend-based, and this is what most government departments do. So they work out what they spend, and there's a figure associated with that spend, and that's it. So it's compliant, but it really doesn't help them to figure out how they're going to reduce their emissions. There's then a set of online tools where you can put in some information, and it will, again, give you back a figure. Again, it's compliant, but doesn't really help you figure out exactly where your emissions are coming from. In most cases, what you want to be able to do is be able to say, this is finance, here's the emissions from finance. This is my laptop estate, here's the emissions from my laptop estate. What can I do about that? How can I change it? So this is where a customized model comes in, where we have to build in how long they're keeping the devices for, where they're buying them from, which ones they've got, how they're being managed, how many hours are they being used, all those sorts of figures go into the model. The challenge is the spend-based stuff is free, and free is very attractive to government. The online tools are easy and pretty cheap. Building an effective model takes a bit of external consultancy time and costs some money, which clearly is a problem at the moment, given the economy as it is. So what are we looking at? What actually contributes to carbon footprint from an end-user computing perspective? So there's what's called scopes of emissions, which are 1, 2, and 3. Relatively simple. Scope 1 is emissions from things that the organisation owns. So that if it's a factory, that could be a factory that's burning gas in order to heat furnaces and things like that. From an IT perspective, it's mostly chiller units within data centres and cloud facilities. Then there's phase 2, which is use phase carbon. So that's using electricity from the grid and the emissions that are caused by somebody else generating that electricity for you to use. 90% of an organisation's emissions will be scope 3. From an IT perspective, that's embodied carbon. So that's all of the emissions from getting the resources out of the ground, making the device, shipping it, packaging it, and then disposing of it at end of life. But it's also the emissions from the supply chain of the people who deliver it to you, unpackage it, configure it, and take it away again, who service it, maintain it, upgrade it, and repair it. And it's also the emissions of those people traveling to and from work and for work. So commuting, business travel, all those good things. And also waste, including e-waste. So if we look at the variables, and this is what organizations who are trying to measure and control carbon emissions are struggling with, the variables from an end user computing perspective are huge. So the footprint of a device will be determined by how it's designed, what CPU it uses, what operating system it uses. Again, we had the gentleman presenting from iGel earlier, who said they've got a very low footprint OS. It's absolutely true. So have Google, Chrome OS Flex. Their operating systems, because they're Linux-based, are typically about 19% lower in terms of emissions than running Windows on the same device. So there's a significant difference there, purely based on the operating system. We'll talk about where you use it in a second. How you manage the power on that device. How often is it powered down? Is it powered down overnight, over the weekend? What workloads are you running? And are you running those locally or in the cloud? Has a huge impact. How many hours a day do you run it? So again, we can build that into those custom models, but otherwise you're based on very broad assumptions. Then there's what's the device made of? Where in the world is it made? How is it packaged? How is it transported around the world? Is it being flown on an airplane or put in a container ship? But probably the biggest impact, and particularly around the circularity piece, is how many years do you use that device? What happens to it when you're finished with it? Does it go to somebody else in your organization? Does it go to another organization? Can it be repaired, upgraded? Can it be repurposed? And ultimately, can it be recycled? So what we end up doing is having to look at all of this into a combined score for the sustainability of a device, and providing a breakdown of how those scores are made so that organizations can look at a potential list of devices they might buy and get a metric on all of these so that they can look at those and decide what's most sustainable. So we're going to drill in on there, just on scope 2. Now remember, the scope 2 is the simplest thing.
And how many organisations?
I thought that was 5 minutes. I was worried then.
No. How many organisations you work with that are actually seriously taking notice of these scores in their purchasing decisions?
Mostly in education, finance, and across government. I would say every government department is probably looking at these. Certainly working with a couple of high street banks, a couple of major accounting firms, all of whom are using these matrices. Yeah.
Cool. And it's also 5 minutes.
So, scope 2 emissions, again, this comes from burning electricity. It's about 15 to 20% of the total carbon footprint of a smartphone or a laptop. It's about 25 to 40% of a desktop. If you get to networking equipment, it's about 50 to 80%. So again, we do get people saying, can I buy a new laptop and will it reduce my carbon emissions? If you make 20% saving in the power that uses, it's only 20% of the carbon footprint, so you're possibly saving 5% of the overall emissions. The one you've got at the moment is definitely, you keep using it for another couple of years, it's a far better proposition for the planet. Where you run it has a huge impact. If you run that laptop in the UK, you've got 2.7 kilos being produced. USA, the same workload is nearly double. India, it's more than treble. France, a bit less. If you run it in Iceland, there's almost no emissions because they're using geothermal energy. So I know of a startup company that bought £1 billion worth of networking equipment to set up zero carbon cloud services in Iceland. So in terms of what we're going to do, I am going to run a couple of minutes over, apologies. First thing is get that planning in place. Understand what you're trying to achieve. get the baseline in place and start to look at how we can reduce those emissions and also use IT not just to make it a smaller part of the problem, but a contributor to the solution across the organisation. Embrace circularity to make best use of what you have already, whether that's software, whether it's hardware. Make best use of it for as long as possible. But also, and you'll see this increasingly, demand metrics from your suppliers about the services that they provide to you. And again, you'll see this across government and then into the private sector, asking for metrics about what the carbon footprint of supply is, specific to you as a customer. This all then flows through into procurement. So again, we're working with the Crown Commercial Services around setting minimum thresholds so that basically there's guidance about what the minimum standard you should expect from a supplier, whether it's a product or a service, in terms of the reporting back. If you can't provide that, you will not be supplying to the public sector. It's as simple as that. But getting users engaged and involved is absolutely critical. So this is a program we worked on with Imperial College. Again, what we worked with them was looking at their devices and their procurement, but also their user behaviours. So what user behaviours could we encourage and what impact would that have on their overall carbon footprint? And so they came up with this superhero challenge. Shut the lid, save the grid. Nice and catchy. So the final thing I wanted to touch on was just some facts and figures, because you're that kind of an audience. Worked on a project for a FTSE retail organisation and looked at their planned Windows 11 upgrade and instead replacing that with a combination of alternative operating systems and lower energy devices, in their case Chromebooks. So we calculated they could save 32% of the energy they were currently using and therefore bring their Scope 2 emissions down by 32%. They could reduce their Scope 3 emissions from embodied carbon by 40% by exactly as we said earlier, skipping a refresh cycle, and they'd make a 23% capital cost saving, taking all of the licensing and the services and all the packages into consideration. Equally, just worked with a large university in the north of England, looking at their labs and not provisioning high-end devices across all of their labs on campus, and instead streaming applications via AWS app streaming. So we worked out that we could reduce their on-campus energy by 78%. We also worked with AWS to actually calculate the emissions of the energy used in the AWS cloud and the Scope 3 emissions of the servers used in the cloud to deliver the service. And we added all of that in. They were still saving 25% of the Scope 3 emissions because they weren't buying a whole load of high-end compute devices, which frankly sat there most of the time doing nothing. And they made a 28% cost saving on that. And that's being presented at the UCISA conference, which is the big UK higher education conference, which is taking place next month. And the final point, and this is actually fundamental because none of this works without networking. So we worked with one of the larger central government departments. We looked at their networking, so replacing a legacy infrastructure of very old devices. And if you noticed it in the previous slide, networking devices, it could be 50 to 80% of their carbon emission is just from the energy that they burn, because in most cases they're on 24 hours a day, 365 days of the year. So upgrading those devices at end of life reduced their energy by 79%. Comparing it with the devices that they had with the new ones that they bought and we're going to keep for the next 5 years, 63% lower Scope 3. And also, I'm very happy for central government, saved £147,000 a year in energy costs. So the takeaway is that sustainable IT is not the more expensive option. It's the better option for the customer. The only people who are suffering from this by going for the non-sustainable option is the people who make money out of keeping everybody on the IT treadmill as much as possible.
For the government customer, what happened to all those network devices they upgraded to the old ones?
So they're going into recycling, yeah. they are end of life, so there isn't anything that can be done for those. So wherever possible, if a device has a useful life in it, then obviously we're encouraging those to be either resold, or I wouldn't say donating them to charity is the wrong way to put it. If they can be repurposed properly and supported within a customer environment, then that's a valid thing to do. The problem is a lot of the stuff that supposedly gets donated to charity is put out without any support and ends up not being used. So there's a real challenge around donations to charity, which is a separate issue. So, any other questions?
So that's all based on sort of the hardware aspect. What about software? So whilst, converting devices to Chrome OS and Flex, but if they enable Gemini as an AI tool within that, what's sort of the sustainability of that, and how does that impact that? Because, you've got lots of different sort of AI tools that generate and are hosted in cloud services. How does that impact sort of figures?
So, I mean, where you run the workload obviously has a big impact, as does the capabilities of the client device. So, basically, it's running those where they're most efficient. If I take the Cloud Labs example, those devices would all have been AI capable and would potentially have run some of those AI compute, if you like, locally, but they would only be used 2% of the time, whereas if it's used in the cloud, those resources are being used 100% of the time. So it's efficiency of where those resources are used. One of the big issues with AI is not just that it uses a huge amount of compute and energy in the data center facility, it's that it's being built by the manufacturers into the client devices, which then in most cases are only being used for 25% of the working day. So all of that capacity is sat effectively unused. So from a sort of embodied carbon perspective, it's a huge waste of resource. So it's a balance. Yes, running AI in a data center, it's a huge sprawl of compute facility that's being used to generate pictures of cats in uniform, pornography, and God knows what else. And this is one of the big arguments, because it has huge beneficial opportunities for mankind, but not for what we're currently using it for, to put up some additional information on Google searches we didn't ask for. So kind of, I'm conflicted on the topic, if you can't tell.
Maybe a tricky one to answer, but from testing we've done, we found that an i5 laptop will give us an average about 3 to 4 years of life expectancy. If we upgrade that to an i7, we can probably get another year out of it. We also see that an i7 draws more power and consumes more resource than an i5.
Yep.
Therefore, is it better to buy an i5 and replace it more frequently, or is it better to buy an i7 that gives an extra year but uses more power for the duration of its life?
It's better to buy an i7 because, as I say, if you look at that balance of total carbon footprint over the lifespan, that 85% of the carbon footprint for that laptop is coming from the resources, the manufacturing, and the shipping of that device around the world. So even if it does pull 20% more power, then that's probably, you'd have to keep the laptop for a lot longer in order to justify it, which you're not going to do. They'll still become obsolete. So if you can have something that lasts for 5 years, it's going to be far more effective than a lower energy machine that runs for 4.
Thank you.
Yeah, thank you very much.
Okay, thank you very much.